Okay, so the last lesson was everything that we do about graphs of rational functions. Now we're going to be doing simplifying rational expressions, and we spent 2 days on that. The first day we will be simplifying first, then multiplying, and then dividing. Okay. And because rational expressions means they're written as fractions, it's going to be similar to how you operated with simplifying fractions or multiplying fractions or dividing fractions. Okay. What we're not doing today is we're not going to add and subtract. We save that for next time. Which do you think is harder? Multiplying and dividing or adding and subtracting? Adding and subtracting because you need to find a common denominator, right? That makes it different. It makes it harder. So the next lesson is probably the hardest. So first, before we simplify a rational expression, we're going to simplify a fraction. And I've got some steps here, especially in a class like this. You may not even do it exactly like this, but I'm showing it exactly like this because it has more to do with what we're about to do. Factor the numerator and the denominator, right? 6 over 8 has a common factor. What is it? What is the common factor, right? Answer the question. 2 times 3 over 2 times 4, right? Once it's factored now, since there is a common factor in the numerator and denominator, you can cancel them, right? So you cancel these, and the simplified fraction is 3/4. So when can you cancel numbers from the numerator and denominator? When they are factors of the entire numerator and the entire denominator. For example, if I wrote the 6 over 8 like this, 6 over 8 equals 4 plus 2 over 6 plus 2, can you cancel the 2's? Because are the 2's factors? No, because factors multiply. And that's another term. It's not something that's multiplying the rest of the numerator. It is another term in the numerator. So you can't cancel the 2's. And look what would happen if you did, right? If you cancel the 2's, then you would get this equals 4 over 6. Is 4 over 6 the same as 3 over 4? As a decimal, 3 over 4 is 0.75. What's 4 over 6? Or 2 over 3? 0.6 repeating, right? That is not the same thing. That's why you can't just take one term from the numerator and one term from the denominator and cancel. And we do that all the time, believe me. That is a mistake that will be made over and over again. I'm sure we'll have more chance to show that as we're going through here. Okay, now we move it to a rational expression. So we only had 2 steps to simplify a fraction. Now we got 3 steps to simplify a rational expression because what did I have to add to this list? To state the restrictions part, right? We didn't have to worry about dividing by 0 when we just had numbers in the numerator and denominator because those numbers were never 0 in the denominator. Okay? But now we do because we've got variables in the denominator. So we've got to restrict the x values so that we don't divide by 0. Right, so first step, factor the numerator and denominator. Okay, this is why this is hard, is you've got to do some factoring, which may have been difficult for you back in chapter 4 when we did it. And now you're being expected to do it, 2 times, 4 times in the same problem. How do we factor the numerator here? Remember, what kind of factoring did we call that in our? It's a simple quadratic, right? What makes it simple? It's 1x squared, right? Because it's 1x squared, it's a one-step process. All you have to do is think of what are the factors of 10 that add up to 7? Okay, 5 and 2. So how does that create my factors? What are my factors? X plus 2 x plus 5. Okay. How about x squared minus 3x minus 10? How's that going to factor? Negative 5, positive 2. So that's the first step. Factor the numerator and denominator. Okay, now state the restrictions so that we don't divide by 0. Basically, find the zeros of the denominator. Zeros of denominator. Okay, what are the zeros of the denominator? 5, negative 2. So you're going to say the restrictions are x does not equal 5 or negative 2. Check. Okay, now cancel the common factors, if there are any, from the numerator and denominator. What's the common factor? There's an x plus 2 in the numerator and denominator. So you cancel. And what's left is x plus 5 over x minus 5. Okay, and the answer, the total answer is this. X plus 5 over x minus 5, but x does not equal 5 and x does not equal negative 2. If you were just looking at this, you would not have thought that negative 2 would have been a restriction. But that's why you got to state the restrictions before you start canceling factors, because negative 2 would have made that first denominator equal 0. So you still have to include it. Now, can you cancel the 5s? Can you cancel the x's? No. Right? Those are terms, not factors. So you're done. That's the last step there. So check, check, check. Factor the numerator, factor the denominator, state the restrictions, cancel the common factors. Okay. So you try this one. It'll be a you try to be handed in. Right? You got the reminders of what to do right there. Take it one step at a time. That's good. That's good. Got one winner. Okay. Good job. There's another. Got to know how to factor. Right, Ashley? Correct. Good job. Incorrect. So You factor these correctly. State the restrictions before you start canceling. And where do you look for them? Right. So why do you got -4? How we doing? Oh, that's this one. That would be +2. Since it's x minus 2, it's +2 that x can't equal, right? 2 minus 2 is just a wrong sign there. If these two numbers add up to +2, it doesn't have to be positive. That has to be negative. Digestion. Remember, you're stating the restrictions because they're the zeros of the denominator. The numerator's got nothing to do with it. There should not be a -4. They're coming from here, 2 and 3. Remember, you do that before you cancel. Yes. So, right, again, if you need to go back and look at factoring, then you need to go back and look at factoring, because these are really pretty basic factoring problems, right? The factors of -8 that add up to 2, +4, -2, right? Okay, and then the denominator, the factors of 6 that add up to -5, x minus 3, x minus 2. So remember, this is the point where you state the restrictions. And where do you look for them? In the denominator, right? So they are, x does not equal 3 and 2. Okay, then you cancel common factors. And what's left is x plus 4 over x minus 3. You did pretty well on that. Now there's a couple that are common mistakes, not necessarily mistakes, but things you got to look out for here, right? This is not a you try. This is just me showing you another example of simplifying, right? How would I factor the numerator of this one? What's the common factor? 4, right? So this is 4 times 3 minus x. And how do you factor x squared minus 9? It's the difference of squares, right? We're supposed to recognize that pattern and go immediately to x plus 3 times x minus 3. I mean, you're going to see that there's all kinds of difference of squares embedded in these problems. And the reason they're in there is because they're supposed to be easy factorings, right? If they're not, then miss the whole point of it there. Now, what are the restrictions before I? 3 and -3, right? X does not equal 3 or -3. Okay, now are there any common factors? No, 3 minus x does not equal x minus 3. However, you should be thinking, what would happen if I switched the order of the subtraction? It wouldn't be equal. What would it be? Yeah. Well, if I switch the order of it, it would be -x plus 3. But if how does 3 minus x compare with x minus 3? For example, here's a specific example. What is 3 minus 1 compared with 1 minus 3? They're opposites of each other, right? When you switch the order of subtraction, you make them opposites. So you can deal with something like 3 minus x by switch the order of them and then put a negative out front. right? That'll balance the fact that you just made it negative, then put a negative out here. Or if you want, you could just think of it like factoring out a negative 1, right? In any case, if you rewrite this like negative 4 times x minus 3 over x plus 3 times x minus 3, now you do have a common factor, right? You should not leave it like this. You should make sure that you cancel an x minus 3 and put a negative there, right? Because again, when you just switch the order of subtraction, it makes it the opposite. And by putting a minus in front, that balances out what you just did. So now I cancel, and this equals negative 4 over x plus 3. I think there's 1 or 2 of your homework problems that have a factor like that, where it's they're just the order is reversed of a subtraction. So just know what to do. Flip it and put a minus sign in there. Okay, another one that confuses us to no ends is something like this. The very first step says factor the numerator and denominator. Okay. How many terms are in the numerator? No, these are factors. 1. Terms are separated by pluses or minuses for subtraction, right? So if you don't see any adding or subtracting going on, that's 1 term, which means there's nothing to factor. There's nothing to factor. There's only 1 term. You factor when there's more than 1 term, when you can. But when there's only 1 term, there's nothing to factor. Right? Same thing in the denominator. There's no addition or subtraction going on. That means there's only 1 term. That means no factoring. So this first step right here you say is NA. Not applicable. Okay. 1 term, so no factoring. So cancel. Okay, now you still got to move ahead to the next step. State the restrictions. What values of x and y do you need to restrict so that you don't divide by 0? 0, right? X does not equal 0, y does not equal 0. Remember, we did this when we had factors that were, if you had like x times x minus 2, remember you'd say, since it's a standalone x, the 0 is the 0. I mean, if you want, you could think of this like in parentheses, x minus 0 squared. Isn't that the same thing? And what does that make the 0? 0. So when you get a standalone x, it's not x plus something or x minus something, then 0 is the restriction. So right away I'm going to write this down here. X does not equal 0. Y does not equal 0. Okay, now at that point, we're simplifying this. This is kind of like when we did the properties of exponents at the beginning of the chapter on radicals. I mean, that's all that is. Simplify. The 24 over negative 6, negative 4. Right. X to the third over x squared. What's that? Yeah, I mean, if you think of it as properties of exponents, you would say 3 minus 2 is 1. So it gives you an x to the first in the numerator. And what about y squared over y to the third? If you do it like a property of exponents and subtract, right, 2 minus 3, then you would have y to the negative 1. But then you'd have to get rid of the negatives. And how do we get rid of negative signs in the exponent? You flip to the other side. So this becomes negative 4x over y. Now, if I was simplifying this for myself, I would probably just say, okay, x squared, that will cancel with 2 of those, leaves 1 behind. Y squared would cancel with 2 of those and leave 1 behind. And then just go from there. Not actually take a step where I go y to the negative 1. And it's a higher power of y in the denominator. You know they're going to be in the denominator. Okay. So those are the 2 kinds of problems that I think are trickier for us. When there's actually nothing to factor at the beginning. and when the order of subtraction is reversed. So you got to like do something so that you can cancel. And you will have some homework problems like that. Okay, now we're going to go on to multiplying rational expressions. And before we do that, we're going to multiply fractions, right? Because rational means fractions, right? What are the mechanics of multiplying fractions? No, Lee, you do not do cross multiplication. That's when you're solving proportions. You just go straight across, right? Okay. So let's say you go 6 times 7 over 5 times 8. And then you go 42 over 40. And actually, there's a common factor. We could simplify this, right? I could write this like 2 times 21 over 2 times 20. And that cancels the 2's, 21 over 20. Or you could, and this is probably more like how you're going to do it with rational expressions. Somebody bothering us? Yeah. Okay. No, you'd probably factor and cancel first. You wouldn't. You're not going to end up multiplying everything together and then canceling common factors. You would probably, write this like 2 times 3 over 5 times 7 over 2 times 4, and then cancel the factors, the common factors, numerator and denominator. It doesn't even matter that they're not in the same fraction, because in the end, when you multiply, you're just going to run everything together anyways. So now I cancel those, and all that's left when I multiply across is 21 over 20. Good. A couple of right. Trey, done? Good. Bergen? Everybody? Okay. So now we're going to do is rational expressions. Of course, I got to add one more step than I had with fractions, and that same thing, state the restrictions. It's something you don't have to worry about when you just have numbers involved. So first step, factor the numerators and denominators. So you can have, if you're multiplying two fractions, you could have up to 4 factoring problems inside. So the first one, how does that factor? Too late. Should have come to you much faster than that.
3 negative 2.
Okay, x plus 3 times x minus 2. Okay, x minus 5 times. Okay, x squared minus 25.
X plus 5.
Yeah. And how about x squared plus 4x plus 3? 6. x plus 3 times x plus 1. Okay, so again, you're just going to have to remember how to factor things. And they could actually be more complicated. Remember, what was the hardest kind of factoring we had to do? The one where the a wasn't 1, right? Then you got to do the for a times c, find the factors that add up to the b, split the middle term, all that stuff. They can have those as part of it also. Okay, so that's the factoring part. Now because we have two fractions, you're going to have to look for the zeros of both denominators. Zeros of denominators. Plural. So what will that be? X does not equal 5, negative 3, negative 1. Right? Don't even look at the numerators. Numerators got nothing to do with it. 5, negative 3, negative 1. Check. Cancel common factors. Right? Again, they don't have to be in the same fraction, because in the end they will all be in the same fraction. What are the common factors you see? Okay, there's an x minus 5 here. Yeah, x minus 5 cancels with x minus 5. X plus 3 cancels with x plus 3. Anything else in common? No. So then that was that. Now we can just multiply everything together. X minus 2 times x plus 5 divided by x plus 1. X plus 1. What is the 0 that comes from a factor of x plus 1? Yeah, that's why it's there. Good, good. Okay. So you try that one. Try to do the same thing. Yeah, this is a you try. You try. The second one. There's only 3. Were you watching last night when it ended? You must have been going, we're going to lose, we're going to lose, we're going to lose. Oh my gosh, we won. What? How do you factor x squared minus 16? How do you factor 2x minus 8? You factor out of 2. So remember, if it's not a difference of squares and it's not a quadratic trinomial, then look for greatest common factor. That's another thing we get stuck on sometimes when that's part of the problem, which really ought to be even easier, but we turn it into something hard. How'd you do? Still working? You didn't factor the 2x minus 8. Take out a 2. Doesn't 2 go into both of those? Okay. Did you finish it? How about John? John got it done? Let's see about this. 2 times x minus 4, x plus 4. That's good. That's good. We'll just state the restrictions before you start canceling. Yeah. Get it there? Let's see. Where's the negative 2?
Oh, sorry. I was just
2 times x minus 4. X plus 4 times x plus 1. X plus 4, x minus 4, x plus 4. So you canceled these.
Yes.
You canceled these. And what's left? 2 times x plus 1. Why is there 2x plus 1? You canceled that, or you canceled that? Just 2 times x plus 1. Okay. And the denominator, there's still an x plus 4 times an x plus 4. Okay, so just that 1 is extra. Everything else is right. Okay. Okay, let's see about this. So again, when you got to always be on the lookout for greatest common factor. For 2x minus 8, the common factor is 2. So 2 times x minus 4. Right? Difference of squares, x plus 4 times x minus 4. Times. Okay, x squared plus 5x plus 4. X plus 4x plus 1. And x squared plus 8x plus 16. X plus 4. In fact, you could write that like x plus 4 squared, but sometimes for canceling purposes, it's better to have it written out like that. Okay, what are the restrictions? X does not equal what? 4 and negative 4. And then these are both negative 4s anyway. So 4 and negative 4. Cancel. X minus 4 cancels x minus 4. X plus 4 cancels x plus 4. Anything else we can cancel? No. So this equals 2 times x plus 1 divided by x plus 4 squared. You have a question, Curtis? Quiet, please. What, Curtis? How? It's got to be one in the numerator and one in the denominator. So we canceled these x plus 4s. Now they're gone. Now these two are both in the denominator, so they don't cancel each other out. They become x plus 4 squared. Okay, which leaves us one last task here, dividing. So remember the process for dividing, right? dividing by a fraction is like multiplying by the reciprocal, right? So there's a first step when you're dividing rational expressions, just like there's a first step when you divide fractions, is you rewrite it as a multiplication, right? Change it to a multiplication. Flip and multiply by the divisor. Like a problem like this becomes 2/3 times 5/4, right? And at that point, everything you're doing is just like the multiplication that we just did. So first step, turn it into a multiplication problem, and then follow the steps for multiplication with one caveat, which we'll look at when we get to the next slide. We'll see that difference. Yeah, with one exception, which we see in the next slide. Okay, so now at this point you can, go 2 goes into 4 twice. This is 5, 6. What's that? No. You don't flip the first fraction. You only flip the second fraction. Right? 4/5 becomes 5/4. Okay. We're good? Bergen? Trent? Natalie? Okay. So now, again, we had to add a step when we go from fractions to rational expressions that includes stating restrictions. So the first step is going to be, let's turn it into a multiplication problem. 2 minus x over x squared plus 2x plus 1 times, now what goes after? Put the x squared minus 1 on top, and in the denominator, x squared plus 3x minus 10. Right? Check. I'm going to go to the next slide, but I've got it rewritten there. So I turned division into multiplication, and I rewrote this is already on the next slide. That should have been your next step. What are we supposed to do now? Factor, right? So factor everything. Now, I'm going to save this 2 minus x. Notice we got that 2 minus x. You can probably figure there's going to be an x minus 2 somewhere, which means we're going to have to flip. So before I do this though, let's do the other 3. All right, this will be x squared plus 2x plus 1 is 1 and 1, right? That's x plus 1 times x plus 1 times, and x plus 1 over x minus 1 and now that'll be x plus 5, x minus 2. So again, there's a 2 minus x that is supposed to be here. But you can see that there's a factor of x minus 2 in the denominator here. So in order that they are the same, then I can cancel them. I'm going to, in the step that I'm factoring, I'm going to rewrite this like x minus 2, which means I have to put a negative in front of it. Right? By switching the order, I made it opposite. So I put a minus in front. So I just, on this side, I've already rewritten what we just did on that side. We'll do the rest on this slide here. In fact, if we're done with that, let me go back to this right here. Okay, when I'm looking for restrictions to the domain, right? Restrictions on the variable x. Remember, most of the time, where do we say we look for the restrictions? The denominators, right? But how many different denominators do you have when you divide a fraction by a fraction? I mean, this is a denominator, right? Because that fraction bar means divide. This is a denominator because that fraction bar. But actually, you've got the divide symbol between them too. So there's actually a third division going on, right? And what is going to make this fraction equal 0? We're not talking about the denominator anymore. What makes the whole fraction equal 0? When the numerator equals 0, right? For a fraction to equal 0, it's because the numerator equals 0. So that's a third place we've got to check. When you do a dividing by rational expressions, you have to check not only the two denominators, but you also check the numerator of the divisor, right? So that that whole second fraction doesn't equal 0. So we have to check here, here, and here, right? The only place you don't check is there. So we say, state the restrictions, the zeros of denominators, right? And numerator of the second fraction, the divisor. Now, in truth, once you've turned it into a multiplication problem, you've kind of mixed up the sense of what was the denominator and what was the numerator of the second fraction, right? Because we flipped that to get where we are. But it doesn't matter because you got to check them both anyways, right? You're going to check 1, 2, 3. So what are the restrictions here? X does not equal -1, -5. Okay. -1, -5, +2, and now there's a -1, but we already have a -1, and there's a +1. Right, that's the state of the restrictions. Again, you're looking all three of these here. And now cancel common factors. Okay, there's an x plus 1 and an x plus 1. And you got an x minus 2 and an x minus 2. Anything else? It doesn't look like it. No. Let me write, first I'll write it like this. Right, this equals negative x minus 1 divided by x plus 1 times x plus 5. Now, the minus, could you distribute that? Sure. I mean, you could make that negative x plus 1, which would be 1 minus x. You get back to that same reverse order, but it doesn't matter. So cancel the common factors, multiply numerators, multiply denominators. So one more you try for you. You ready? Get your pencils sharpened. We got the steps are right there. I can tell you that this usually goes down pretty hard, and you have the advantage. You're doing homework. If you're confused, watch the video. But have the video up of what we were doing while you're doing the similar problems. And you're going to have 3 simplify, 3 multiply, 3 divide. I think there's a couple more because you're the higher class after that. And you're so lucky. And everything that I'm saying and what you're saying and everything. You didn't check out yet? We're in second semester now, Josh. You haven't looked at one yet? Okay. So first make it a multiplication problem, then factor. Which is the hardest factoring? Okay, what kind of factoring are you going to do on the 2x squared minus 6x? Greatest common factor. What's the greatest common factor between 2x squared and 6x? 2x. So factor it out. Again, don't turn those into harder problems than they need to be. Greatest common factor is supposed to be kind of an easy one. Everybody should have that, right? That's just mechanics. Yep. Yeah, that's true. If you factored out a 2x, that's still a 6. Right here. You're getting it. Just got to finish that one right there. check the factoring. Do you get the factoring right? Okay, restrictions. If you got all the factoring up to that point, then what are you going to say are the restrictions? Yeah, Curtis. Yeah. Okay. John, quiet. Let Curtis say again. Okay. Right. Don't forget that 0 is the 0. When it's just 2x, it's not x plus something or minus something. If you substitute x equals 0, it makes the whole numerator equal 0. So you have to say the restrictions are all of those. -4, 3, -1, 1, and 0. Okay.
Wait, I have a question.
C.
So, when you're writing the restrictions, do we do x doesn't equal?
Yes.
Okay.
Yeah, you're restricting those values from x. Okay, now, what are the common factors? There's the x plus 4s, x plus 1, x minus 3. Anything left? Okay, so that is, all that's left is 2x over x minus 1. Is that fun or what? You good? Okay, good. Okay. Okay, so quiet, please. So we did simplify, multiply, and divide. Next time we add and subtract. What's that? I'm just giving you, these are what the SOLs say. So they list the add and subtract first, and then the multiply and divide. This will be the same thing on the slide next time, and we'll underline those two. We do add and subtract last because it's harder, because you have to find common denominators. Well, okay. What is that? Well, you can judge for yourself. You can judge for yourself on Wednesday, okay?